Hello everyone, welcome back to the video lecture series of Electrical Circuits and Network. In the previous sessions we have discussed what is CDR and VDR and how to solve the numericals based on that. In this session we are going to discuss few more examples based on this CDR and VDR technique. So let's get started. The first question is, the circuit is given where 6 ohm and 4 ohm are connected in series with each other across a 24 volt DC supply. Here question is what is the value of this V1 and V2? So which technique we will use here? Here we will use VDR, voltage division rule. Okay, so according to voltage division rule, the voltage across V1 is the voltage across 6 ohm is nothing but total voltage is what? V into same resistor 6 divided by sum of all to 6 plus 4. So it will be what? 24 into 6 divided by 6 plus 4 is 10 is nothing but 14.4 volt. Okay, this is the value of V1 we got. Similarly, V2 will be what? Total voltage, which is nothing but 24 volt into V2 is the voltage across 4 ohm, so 4 ohm divided by total resistance 6 plus 4, and it gives the value 9.6 volt. This is the value of V2, that is voltage across 4 ohm resistance, and this V1 and V2 should be 24 volt. So let's check. V1 is 14.4 volt and this V2 is 9.6. So 14.4 plus 9.6 is nothing but 24 volt. That means our answers are correct. Okay, in this way we can find the voltage distributed across various resistances when they are connected in series with the help of voltage division rule very easily. Okay, now let's take another example here. 3 ohm and 3 ohm, three resistances are connected in series across 60 volt supply. DC supply is applied. Here again we have to find the voltage across each resistor V1, V2 and V3. So here also we are going to use VDR, voltage division technique. So let's get that V1 is nothing but voltage across 3 ohm. Okay, so total voltage is 60 into 3 ohm divided by total resistance. As they are connected in series, the total resistance will be 3 plus 3 plus 3, which gives value of 20 volt. Similarly, V2 is 60 into, this is the across again 3 ohm, so 3 plus 3 plus 3, which gives value again 20 volt. Again V3 is total voltage into V3 is voltage across 3 ohm, so 3 divided by 3 plus 3 plus 3, which gives the value of 20 volt. In this way the voltage across each resistance can be found out. Here observe that the 60 volt supply is given to the circuit which across these three resistances. Okay, 3 ohm each of 3 ohm. So what will be the voltage division? As the resistances are same, the voltage across them also same, 20 volt, 20 volt, 20 volt. So we can directly write it as V1, V2, V3 are equal because the resistances are equal. So which nothing but 60 divided by 3 is 20 volt. In this way also we can find the voltage across each resistance when the resistances are identical to each other. Okay, this is the shortcut method. Okay, now let's take another example. Here the question is what? The circuit is given where 10 ohm and this 5 ohm are connected in parallel, and this total current flowing through the circuit is what? 10 ampere. 10 ampere is the total current flowing through the circuit, and here we want the value of this I1 and I2. So which technique is useful here, CDR or VDR? Here current division rule is applicable, okay, because current is distributed within these two branches. So CDR, use CDR here. CDR says that when we want to calculate the current through any branch, take total current into the branch opposite to the branch. This I1 is flowing through this 10 ohm, okay. So take opposite branch resistance is nothing but 5 divided by total resistance 10 plus 5, okay. This is 10 into 5 upon 15 is nothing but 10 upon 3 ampere, okay. 3.33 ampere. Similarly, I2 is what? I2 is total current flowing through the circuit which gets distributed into these two branches. Then I2 is current flowing through 5 ohm. So its opposite resistance is 10 divided by again 10 plus 5. Okay. So this will be what? 10 into 10 upon 15 is nothing but 20 upon 3, which gives the value as 6.67 ampere. Now check the values are correct or not. The sum of this I1 and I2, from diagram we can write that I is equal to I1 plus I2. So let's check that. 3.33 plus 6.67 should be 10. So 10 equals to this 3.33 plus 6.67, we have got this value. So it will be nothing but 10 ampere. So our answers are correct. Okay. In this way we can find the current distributed among these two branches. Similar example is here. 20 ohm and 10 ohm are connected in parallel and total current is what? 5 ampere through the circuit. Here also we are going to find the values of I1 and I2 directly with shortcut method. Okay. I1 is what? 5. Total current is 5 divided by opposite of it is 10 divided by 20 plus 10, 30 is nothing but 5 by 3 ampere. Okay. Second, I2 is what? Total current 5 into I2 is the current flowing through this branch. So opposite will be 20. 20 divided by total resistance 30 is nothing but 10 upon 3 ampere, and the sum of these two will be what? I1 plus I2 equals to 5 by 3 plus 10 upon 3 nothing but 15 upon 3, which is nothing but 5 ampere, and which is the here 5 ampere. In this way we can find the current flowing through these parallel branches with the help of CDR. Okay. Now let's take another example where the question is what? Find current through resistance R3. Okay, where is R3? R3 is here. And we want the value of current, named it as I3. The value of I3 is what? Okay. Here we want to calculate this I3 with the help of which technique? Current division rule. CDR technique. Current division rule. Okay. For that we want this total current, because this is the total current, named it as, suppose it is I1 and current flowing through this branch is I2. Then what? From diagram we can write that I1 is nothing but I2 plus I3, because this total current I1 gets distributed at this point between these two branches. Okay, so I1 will be I2 plus I3 and I1 is the total current. So when we calculate this total current I1, it is easy to calculate I3. So let's find first I1. For that we want to calculate this I1, total current flowing through I1. I1 is what? Total current flowing through the circuit is nothing but total voltage across the circuit divided by total resistance. Okay, total voltage is given 10 volt, but we don't know the value of RT. So first calculate RT. RT is the total resistance of the circuit. total resistance of this circuit from here to rest of the circuit. Okay, so let's calculate first. RT is nothing but this 50 ohm. Okay, this 50 ohm is connected in parallel, is connected in series with this parallel combination of 100 and 100. Okay, we know when 100 and 100 are connected in parallel, what will be its equivalent? 100 into 100 divided by 100 plus 100, which is nothing but 50 ohm. And this equivalent 50 ohm is connected in series with this 50 ohm. So again, this 50 ohm plus 50 ohm is nothing but 100 ohm. So I1 will be what? 10 divided by 100 is nothing but 0.1 ampere. This is the value of I1, total current. So using CDR, we can easily calculate the current through I3 is nothing but total current I1 into, we are going to calculate the current through this R3. So opposite resistance is R2 divided by R2 plus R3. So I1 is 0.1 into R2 is 100 divided by 100 plus 100 is nothing but 0.05 ampere is the value of required current flowing through this resistor R3. Okay, these are the steps we have to follow. We can calculate this answer with this observation also. How? Let's see. Observe that this circuit is given to us where this 50 ohm are connected in series with these two 100 ohm parallel combination. Okay, so in mind we can calculate this 100 is connected in parallel with 100. So two same resistances are connected in parallel, so its equivalent will be half, and half of 100 is what? 50. So this 50 is there. Okay, then this 50 and this 50 are connected in series. So total resistance of the circuit will be 100. 50 plus 50 is 100. 100 is there. So total current flowing through this circuit is what? Total voltage divided by total resistance. 10 divided by 100 is 0.1, and this 0.1 is here also. Here 0.1 ampere is there, and same 0.1 is here. Now at this point, the 0.1 ampere gets distributed in these two branches. Okay, according to the value of R2 and R3. We know that. But the value of R2 and R3 are same. So current flowing through this R2 and R3 will be same because the resistance value is same. So R2 and R3 are same. So I2 and I3 will be same. So 0.1 gets distributed equally. So I2 will be 0.05 ampere and I3 will be also 0.05 ampere. In this way we can calculate the required current with only observation, and with more and more practice you will able to do this within seconds without touching pen and paper also. Okay. Now let's take another example. Here question is what? Find the battery voltage. The circuit is given here where 16 ohm is connected in series with this 2 ohm and 6 ohm. This 2 ohm and 6 ohm are connected in parallel, and with this parallel combination in series 16 ohm is connected. Okay, and this is the total battery voltage within these 2 points. Okay, and we want this battery voltage. Here the current through 6 ohm resistor is given, that is 4 ampere. So let's start. First we will find the voltage across the V6 ohm will be the current through 6 ohm into resistor 6. So it will be 4 into 6 is nothing but 24 volt. Okay. Now the voltage between these 2 points, as the current direction is in this way, so this will be the positive end and this will be the negative end. These 2 points, let's say A and B, the voltage between A and B points is 24 volt, and this is the A is nothing but here also A is there, here also B is there, because this 2 ohm and 6 ohm are connected in parallel, and we know that across parallel combination voltage remains same. So voltage across 2 ohm will be same, 24 volt. Okay. Next, we want the current flowing through this. Let's say 2 ohm is there. Okay, I2 ohm is there. So find this I2 ohm is nothing but voltage across 2 ohm divided by resistance 2 ohm. Okay, and this is according to Ohm's law. So V2 ohm is 24 divided by 2 is nothing but 12 ampere. Okay, this 12 ampere. Now this 12 ampere is flowing through this 2 ohm, 4 ampere is flowing through this 6 ohm. Then what will be the current here? Total current I. Then from diagram we can write I is nothing but I2 ohm plus I6 ohm. I2 is 12 and 6 ohm is 4 ampere. So total current flowing through the circuit is nothing but 16 ampere. This is the total current 16 which gets distributed here, 12 flowing through this branch and remaining 4 flowing through this branch. So total current I will be 16 ampere. Now we want this value of E. Battery voltage E will be what? Between these 2 points. And this point is same. So let's say this C point, then this will be the C, and this B, so this will be the B. So voltage between CB is nothing but E voltage. So it will be the voltage between C and A plus voltage CA plus voltage AB is nothing but battery voltage, and voltage CA is what? Between these two is what? Voltage across 16 ohm plus VAB is nothing but voltage across 2 ohm. So 16 ohm, voltage across 16 ohm is 16 ohm resistance into 16 ampere current is flowing through that. So 16 into 16 plus voltage across 2 ohm is what? 24 volt. 24 volt. This gives the value of 280 volt. This is the voltage, required battery voltage for this given circuit. Okay. In this way, we can find the battery voltage for this given circuit. Okay. Now let's take another example which is somewhat different to the examples we have discussed. The question is here, 3 resistances 50 ohm, 40 ohm and 25 ohm. 50 ohm, 40 ohm and 25 ohm are connected in parallel. Determine its equivalent resistance. Okay. If current in 25 ohm is 8 ampere, find current in the other 2 resistances and total power consumed in the circuit. Here the given data is given, and according to that we have to draw the circuit first so that our calculation will become easy. So 50, 40 and 25 ohm are connected in series, connected in parallel, so they are drawn parallel to each other between these 2 points. These 3 points are same and these 3 points are same and they are connected in parallel. Okay. Now given that the current in the 25 ohm is 8 ampere, so current flowing through this 25 ohm is 8 ampere. We named it as I3. I3 is 8 ampere, so this will be I2 and this will be the I1, and this will be the total current I flowing through the circuit which gets distributed at this point through these 3 branches. So current 3, I1, I2 and I3. So I will be what? I1 plus I2 plus I3 as it is a parallel circuit. Then here we have to find the equivalent resistance and find the current in the other 2 resistances also, and find the power consumed in the circuit. Okay, so let's first calculate the voltage across this V25 or this voltage. This voltage is nothing but voltage between these 2 points or voltage between these 2 points or voltage between these 2 points. So V will be I3 into R3 or I2 into R2 or I1 into R1. Here we know I3 and R3, so we will take that. I3 into R3. So 8 into 25 is nothing but 200 voltage. This is the voltage across this branch. And these are connected in parallel. So all the branches, voltage across all these branches will be 200 volt. Okay. Now, here this 200 volt, from this we can calculate this I1 and I2. I1 will be what? Voltage across these 2 points divided by resistance. So 200 divided by resistance 50 is nothing but 200 by 50, 4 ampere according to Ohm's law. Similarly, I2 will be 200, voltage between these 2 points is 200 divided by 40. So 200 divided by 40 is nothing but 5 ampere. Okay. In this way, we can find the current through each branch. Then, next, equivalent resistance. Equivalent resistance is just 1 upon RT is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. So, putting the values R1, R2 and R3, we will get this value of RT. Next is what? RT we have found. Then current through the two resistance also. The next power. Total power consumed is nothing but P is equal to I square RT. I square RT. The power in the circuit is nothing but I square R. Here total power we want, so total resistance we have to take, and this I also total current. So I is what? I1 plus I2 plus I3. So 4 plus 5 plus 8 is nothing but 17 ampere, and putting the values of I and RT, 17 square into 11.76 will be 3398.64 watt. This is the required total power consumed in the circuit. So, in this way, we can find the various required values of voltage and current in any branch in the given circuit with the help of the CDR and VDR technique easily. In the next sessions, we are going to discuss different types of sources used in electrical circuits and network. Till then, stay tuned and keep learning. Thank you.